Good day, folks. Welcome to my YouTube channel. If you're new here, please don't forget to subscribe. Don't watch my videos without subscribing, and like all the videos, comment, and share with your friends and families. Just continue doing the right thing. Right, today we're looking at the electrolysis, which is the part of the electrolytic cells, which is it's a electrochemistry, and electrolysis of concentrated sodium chloride. It's very important. The word concentrated, there is a diluted sodium chloride there, and the diluted sodium chloride, I'll tell you what's going to happen. Let's look at the concentrated one. In the concentrated one, that means the concentration of chlorine is high, but I'm going to tell you, let's leave that. Now, the sodium and chlorine, sodium chloride, it's dissolved in water. So if it's dissolved in water, it's going to form the chloride ion and the sodium ion. And this is happening in water. It's going to be aqua, right? And aqua, which is water. So what is happening here in this electrolytic cell? There's this, we call this is a brine solution. Is a brine solution. The sodium chloride, when it's dissolved in water, it's a brine solution, right? It's a brine solution, right? So here in this, since it's split into ions, there you have the sodium ion and you have chloride ion, and since it's in water, you have water there, right? The water molecule, it's not only one, right? So what do we have here? We have an anode. We know the anode, that's where the oxidation takes place, and then we have the cathode there. So what is going to happen here, guys? We have three things. We're not only having the sodium and chloride only. Remember, guys, this is a sodium chloride. It's dissolved in water. It's an aqueous solution. That means water is going to be involved. There is a case where it's a molten salt. In a molten salt, it's going to be these two only, no water. It's a melted. The molten salt, it's a melted salt, which is it's a heated salt, right? So now, between the three, there is the one that is going to oxidize. There is the one that is going to be what? Reduced. So the table, so that means there's a competition between the two. So the table is going to help us in the three, the sodium ion and chloride ion and water. Which one is going to oxidize? Which one is going to be reduced? Now, let's look in the table. Let's start with chlorine. Here's the chloride ion there. And we're going to look for the water molecule that is nearby the chloride. We can't take this one, guys, because it's involved chromium. And we can't even take that one. The one that is close here is this one. It's only water. Do you see? And we can't even take this one because this one, it has a permanganate there. So we're going to focus in these two, right? Looking at the two, which one is going to oxidize, is going to reduce, right? If you're looking here between water and chloride ion, the water here, it has a stronger reducing ability, the water, than the chloride ion. But since this solution, it's a concentrated sodium chloride, that means between the two, if you look at the values between the two, they're so close to each other. The values, they're so close to each other, and they're a positive value. So if they're positive value, that means this is the oxidation that is going to take place. Remember, in the terminals of the battery or the cathode is the electrode is positive, so that means the oxidation takes place. So between the two, there is the one that is going to oxidize. But what's going to which one is going to win in the competition between the two? Is going to be chloride ion, because there's a high concentration of that. In other words, if it was a diluted sodium chloride that was used here instead of concentrated, it was going to be what? Water was going to win this. But it's winning because of it's a concentrated sodium chloride. So the water is not winning there. Right? So water, what's going to happen with water? Water is going to undergo the oxidation, right? Water is going to undergo the oxidation. Not water, sorry, the chloride ion is going to undergo oxidation. So the chloride ion is going to be attracted there. Remember, the N ion is attracted is to the anode, right? So when this chloride ion is attracted there, it's going to oxidize there. So when it oxidizes, it's that chloride ion, and then it oxidizes to Cl2, and it gives you 2 electrons, right? Gives you 2 electrons. It must be 2 chloride ions. So what's going to happen here? There will be gas that is formed. Remember, this is the gas that is formed. There will be gas bubbles, this chlorine gas. There will be a gas bubble, which is the greenish yellow. So the color of these gases that are formed here, they are yellowish green, right? So there will be gas there, and there's an oxidation that occurs. This is an oxidation that occurs there. Now, we are done with chlorine, the competition of chlorine and water. Now we're going to have a competition between the sodium ion and water, which one between the two is going to be reduced in the cathode, right? Let's go and look at them. Sodium is up there. Here's the sodium ion. And where's the water? We're going to look for the water that is closer. The water that is closer there, it's that water, right? So between the two, which one is going to oxidize? We are going to look for, if you look at the reduction potential values there, we're going to look with the look for the one with the bigger value. The one with the bigger value is the water. So the water here, it wins the competition between the two, because this one, it has a lower voltage. This one, it has a what? A higher voltage there. So the one that is going to be reduced between sodium and water, sodium is not going to be reduced there, right? And because, and another thing, water here is a stronger oxidizing agent. Water is a stronger oxidizing agent than the sodium ion, which is going to be what? Is going to be reduced there. So what's going to happen when water is reduced? The water is going to be reduced there. So what's going to happen when water is reduced there? It's going to be water, and then it gets 2 electrons, and then it's going to produce the hydrogen and the OH minus, which is the hydrogen gas. So here there will be gas bubbles here, which is, it's a what? It's the hydrogen gas, right? This is the hydrogen what? Hydrogen gas that is produced there. And you will find that in the solution, and now there are OH that are produced, right? When this half reaction, guys, this half reaction is this one in the table. It's this one, right? That half reaction, and I didn't write it correctly as well. So there are 2 water molecules that gives you 2 OH there. So that's the half reaction that occurs there, right? So since there's a OH that is involved, that means this solution is alkaline solution. It's an alkaline solution, which is, in other words, it's a basic solution. It becomes basic, this solution. So now we have what we call, it's a net cell, which is the balance equation between the two. So if you look at the electrons there, you have 2 electrons and 2 electrons, which cancel out. So when you balance the two half reactions, you are going to have two chloride ion plus and water, two water molecules, and then arrow, and then you have a chlorine gas and plus the hydrogen gas and the OH, the two OH minus, right? This is without the spectator ion. The sodium here is acting as a what? As a spectator, because it's not reduced, it's not oxidized there. Guys, this is very important. This is very important for the concentrated. So in a case, if this was a diluted sodium chloride, in the diluted sodium chloride, in both cases, water is going to win. In this case, water is going to win because the concentration of this is going to be what? Low. So water is going to win, and the water wins here. The other way which they ask you this, they put it in an electrolytic cell that is like this. Do you see there's a chlorine gas, which is, this is the oxidation and this is the anode. You can see even the terminals of the battery, it's positive and it's positive. It's going to be a positive electrode, which is an anode. That means the chloride ion, it was reduced here to a chlorine gas, and the water, the chloride, it was oxidized, there to a chlorine gas, and then water here, it's going to be reduced to a hydrogen gas, and then there will be an OH that is there, right? This happens in the concentrated sodium chloride. They ask it like this, or they ask it in this way. I hope that makes sense. Cheers. Bye.